My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 371. In this lecture, we will try to understand mathematical formulation of SVM. This is continuation of my previous lecture, that is lecture number 370, that is 370. I want to just try to recall our initial formulation. W star comma B star means optimal value of W and optimal value of B, which is equal to argmax of over W comma B 2 by norm W. This is also equal to, what is this? Maximizing 2 by norm W is equivalent to minimizing norm W by 2. Therefore, I can write W star comma B star equal to argmax of 2 by norm W over W comma B, which is equal to argmin of norm W by 2 over W comma B. Maximization of this 2 by norm W is essentially 1 by margin. Maximization of f of x over x, which is equal to minimization of 1 by f of x over x, provided f of x not equal to 0, as long as f of x not equal to 0. Using i's, how can I write whole optimization problem? I can write optimization problem as W star comma B star. What is this? W star comma B star equal to, what it says, argmin of W comma B norm W by 2 plus C into 1 by n into sigma I equal to 1 to n ji, such that yi into W transpose xi plus b is greater than or equal to 1 minus ji for every I, and ji is greater than or equal to 0. We saw for every misclassified point, I can write it as yi into W transpose. Yi into W transpose xi plus b is equal to 1 minus ji, isn't it? Where ji, this ji is positive. Ji is greater than or equal to 0. Isn't it? Ji, just like in our previous lecture, we saw that Ji value is 0.5, Ji value is 1.5, Ji value is 2.5. Ji is greater than 0. Refer my previous lecture. For all misclassified points, I can write it as yi into W transpose xi plus b is greater than or equal to 1 minus ji for every I, ji greater than or equal to 0. For correctly classified points, what is ji value? For correctly classified point, your ji is equal to 0. Now, what do we want to minimize? Remember the constraint that we have written. What is this constraint? This is my constraint, isn't it? We want to minimize error, isn't it? What is our intention? We want to minimize error. You have to minimize the error, isn't it? Minimize error. Or we want to minimize misclassification. Minimize error, or we want to minimize misclassification. Misclassification, isn't it? What does minimizing misclassification means? Because ji is greater than 0 for all misclassified points we discussed in our previous lecture. We want to minimize the sum of ji's, isn't it? Just see, we want to minimize the sum of ji, sigma I equal to 1 to n ji. Remember, ji is always positive. That's what we were discussing. Ji is always positive. For incorrectly classified points, my ji is greater than 0. So, in my objective function, earlier I had only margin. Isn't it? Along with margin. Is it, along with margin, if I say I want to minimize the average misclassification. What is average misclassification? As ji is greater than 0, this is related to misclassification. You are adding all these misclassifications and dividing it with n, isn't it? What does it mean? N is number of points. Sometimes you can remove 1 by n. It is average distance of misclassified points, isn't it? This is average distance of misclassified points. For all correctly classified points, ji equal 0. Average distance of misclassified point. This is average distance of misclassified points from correct pies, from correct hyperplanes. Now, you might ask, just see this one, what it says. This is 1 by n sigma I equal to 1 to n ji. This is average distance, isn't it? What is our intention? You have to minimize errors, which is equal to minimizing misclassification, which is nothing but minimizing sigma I equal to 1 to n ji, isn't it? Just see this one. Norm w by 2, it's a margin, that is regularization term. Sigma I equal to 1 to n ji by n. This is, I can say, average distance for misclassified points. This is something like loss, isn't it? Well, now you might ask, what is this C? Here you have C, isn't it? C is your hyperparameter. What is C? C is your hyperparameter. Now you think about, again, let me write carefully. Yes, just try to recall your logistic regression, minimization of W, logistic loss plus lambda into regularization. Here also, what is this? Minimization of, what it says? Minimization of C into, this is loss. Sigma 1 by n into sigma I equal to 1. This is known as loss also. Therefore, I can write C into loss plus what is this term? This term is regularization, isn't it? Now, if you think about it, again, let me write this one. This is C is hyperparameter, isn't it? If you W star comma B star equal to argmin of W comma, same term, isn't it? Now, you can think of this is loss. Which one is loss? Sigma 1 by n into sigma I equal to 1 to n ji I. You can think of this particular term as loss. That's what I am saying here. This term as loss, isn't it? We want to minimize this. You have to minimize the loss. We want to minimize the number of misclassified points, isn't it? We want to minimize number of misclassified points, isn't it? Wherever there is misclassified point, the ji is greater than 0. It is lost to a model which we want to minimize. Norm W by 2 is like relative to regularization. That's what I am saying here. This is just like regularization term. This norm W by 2 is like related to regularization. So in logistic regression, what did we have? Minimization of W, logistic loss plus lambda into regularization, isn't it? Just compare this logistic loss. This particular C, this C is known as hyperparameter. What does it mean? Your C, as C increases, tendency to make mistakes. I will repeat. As C is always positive, as C increases, tendency to make mistakes reduces, means mistakes on training data, which is implies overfit to training. Overfitting training means what? That is high variance model data. When C decreases, norm W by 2 gets more important. You have tendency to underfit. That is nothing but underfit means what? That is high bias, isn't it? Just this is high bias, isn't it? Yes, this is underfit means high bias model. This formulation of SVM is called soft margin SVM. This formulation is called as soft margin SVM. We have seen hard margin SVM. What is the hard margin SVM? Where no errors are allowed. Isn't it? Soft margin SVM is an SVM which allows errors but it says minimize the errors. Just go through this particular lecture. If you have any doubt, please keep a comment. Thank you very much.